Okay, so this is going to be the device overview for the MPOLx, and what we're going to do is do this. So the MPOLx is based on our Smart Class Fiber series of products, which has different applications such as the OLTS85 for doing duplex fiber. So the MPOLx is specific for testing MPO. But the Smart Class Fiber platform has got some common features to it. So one is that you have your test port on the top, and it has a cap so that those test ports are covered by this cap. In addition, for MPO, there's a flap on the port to keep that port clean and keep debris out of it. The Smart Class Fiber products are also available with a patch cord microscope, which we'll talk about in a separate video, that allows you to inspect your patch cords that you would be using to connect things together, but also it's a nice safe parking spot to keep your test cords when you're not actively testing. It has a 1/4 VGA screen that has different elements to it that I'll come back to in a minute, and it also has a touch keypad so that you can navigate either through the touch screen or through the keypad, or if you want, a combination of both. For the MPOLx, there's always a power meter and a source. In this case, the 84 is the multi-mode source. There's an MPOLs 85, which is a single mode source, and when you see the P, it means that there's a patch cord microscope. The P5000i digital inspection probe connects through USB to the unit so that you can use the application for the probe. There's an application for the PCM. You can also use the Sidewinder to do your inspection of MPO. When you're using the P5000i connected to the instrument, it just makes things a little all in one and a little easier to use. This does also come with a hands-free carrier that allows the technician to be working through the racks in a data center, for example, without having to be having their hands tied up by holding on to an instrument. When you look at the screen, you will see there's a home screen which has the different applications in it, and there's the home button so you can always get back to the home screen. There is also, if I start from the bottom, there's also a setup screen so that you can turn on the Bluetooth and Wi-Fi options, which is through a USB dongle. You can adjust your brightness, you can look at software options, help, things like that. So very administrative. In the center, you have the ability to set up your projects, some test profiles that really are used for some workflow, and view what your data storage is. And then you have your main home screen where you see your applications. I'm actually going to start in here and look at projects, because you always want to be setting up a project, and that gives you a place where you save your test data to. So I've got a project here, Viavi Rocks, and you notice that it is active, and I could, by using my menu button, either by pressing the menu or by touching the screen, I can see that I can add, I can copy, or I can set active. So right now the Viavi Rocks is active. If I wanted to, I could set the default to become active, and you notice there is a screen shortcut for that as well. But if you actually want to edit the project, you can go into that menu, you can give it a description, you can tell it what the label prefix is, what the label index is. So I will always have Fiber ID, and then I'll have 1, 2, 3, 4, and I can turn auto increment on or off if I want to. And that's really the bulk of what you have for setting up your project. So I've set up a project, and when I'm at my home screen, you can see in the top left, it tells me what project that I'm in. So that when I come into one of my applications and I perform tests and save results, I'm always going to see, it's always going to save to that project. The probe is using the P5000i digital inspection probe. The PCM is the patch cord microscope, which we'll have a separate video for. And then you notice there's a source application on the source, and there's a power meter application on the power meter. But I'm really going to be focusing in here on the loss length applications in this video series. All right. So we have both an MPOLP and an MPOLs, so a power meter and a source. And then we have the screens where we have the touch screen and we have a keypad. So you can navigate through the instrument by using a combination of the touch screen and the keypad. Pretty much everything that you need to do, you can do from one or the other, but most people find that they use a combination of both. So when you look at the menu, you'll see that you have these different choices down the left-hand side. So I'll start at the bottom, which is all your administrative setups. Under More, you would have your setting, your time, and your date. You can look at your software options. You can turn on Bluetooth or Wi-Fi. The middle is important because this is where you set up your projects. And with the MPOLx, all your projects are set up on your power meter, and then when your power meter is connected to your source, the project information gets sent from the power meter to the source. So when we look at the projects, you can see what projects are defined in the device. You can change which one is active by using the active shortcut on the screen, and you can also, through the menu, you can remove, you can add, you can copy, and you can set active within there as well. When you go and look at a specific project, you'll see its name, and you can either tap on the screen or use the keypad. You can see a description. You can see the label prefix, which is what's going to, all your fibers that you test are going to say fiber ID, and then they're going to have 1, 2, 3, 4 because that's your label index. You can choose to auto increment or to manually increment, and in this case I have the auto increment on. And that, for setting up a project, is really the bulk of it. Now I've used the back button to return, and I can go back one more to get to my screen and tap on my menu here so I see what all test tools are available. In this case with the MPO tester, I have a power meter, so I have a power meter app. I have a source, so I have a source app. I always have my probe, which is my P5000i digital inspection probe, and I have my patch cord microscope, which we'll have a separate video for. The bulk of what people use the MPOLx for is the loss length, which is the next set of videos we'll talk about setting up for a loss length test, as well as performing a loss length test, and as I said already, we'll do a PCM video as well. Right, so in this video we're going to talk about how you set up to do a loss length test. So what's already been done is setting up the project, and we can see at the top the project name is Viavi Rocks, and then we enter into the application by pressing the button for the, tapping on the screen for the button for the loss length. Then we have a menu, so if we tap on the menu, we'll see we have a polarity check, so you can just do a polarity verification of your system, because that's important, because if you don't know what polarity is, you don't know how to set up your pass-fail for polarity. There is a More button in here, which does allow you to set up some things in terms of feet or meters, sound on and off, whether you want to have a negative loss warning on or off. That default is on, and we recommend you leave it on, and whether you want to have an unsaved results warning, which means that if you go to leave the screen where your test results are, it will prompt you that you haven't saved it. So it just prevents you from not saving results. But if you're just testing and don't need to save anything, you may want to turn that off. So that is under the menu again, and that was under More. The key thing that we're going to be using is the test configuration, and this is where you can set up different test configurations and you can set them active, much like you saw with the projects in the earlier video. So in this case, I've created a multi-mode fiber link test and a single mode fiber link test, and you can see that the multi-mode fiber link test is the active one. Much like projects, again, I can add, I can remove, I can copy, and I can set active these different configurations. I'm going to go and I'm going to look at my multi-mode fiber link, so just that you can see what the settings are. And they're quite straightforward. So I have to identify, and notice I am doing this on the power meter, because the power meter is where all your test results are saved, and just much like identical to the projects, your configuration will get sent over to your source when the units are connected together. You will also, if you have this set up wrong, if you set this up to be doing a multi-mode test and you're connected to a single mode source, it will warn you that you have the wrong kind of instrument connected at the far end. For test limits, it is link validation is your option here. There are some preset based on standards, so 40G base SR4, 100G base SR4, and so on. But I'm going to leave it at link validation, and that means I'm going to have to define the maximum loss at the various wavelengths. I have to tell it what expected polarity to expect, and then I will have pass-fail based on polarity. I can set up a length limit, and there was earlier we saw the feet and length setting, so this is set to 3,280 feet. I also have my loss at wavelength 1 and at wavelength 2, so your 1,300 and your 850. And that's really it as far as your setup of your test. That's it for the setup of your test limit. Then you also have to define your cable and connector settings. In this case, we generic MPO OM4. We've got a refractive index, which is important because of your length measurement. And one thing that I should have said at the beginning is that one of the things that makes the MPOLx unique is that it does a loss and a length and a polarity. And there's no other MPO tester on the market that does a proper tier 1, which is loss length, that includes that length test. So the refractive index is important for your length measurement. If this is set wrong, your length can be out. You can tell it the connector type as well. You have to tell it the test reference method, and for MPO, because of the pinned unpinned nature, you really have two choices, a 1-chord reference or a 3-chord reference, and that's it. And you also are able to select which fibers are part of your pass-fail analysis. All fibers are tested, but in a lot of cases, certainly for your SR4 technology, your middle 4 fibers are not used, and so you may want to disable them. It doesn't mean that they don't get measured, it just means that they don't count to the pass-fail analysis. So even if they have excessive loss, you won't fail due to them. And for setting up a test, that's really all there is to it. It's very simple, very straightforward. So in this video, we're going to talk about setting up for a loss length test. I'm going to actually start at my home screen. So when we're at our home screen, we have all of our applications available, and the application that we're going to talk about here is the loss and length. And it's really important to note that it is loss and length as well as polarity, and there's no other tester on the market that does a length measurement. And so you'll see that there's going to be pass-fail for length, and we can also be using length in some of our limit calculations. So I enter into the application by simply tapping on it, and now I'm in that application. And I'm doing all this from my MPOLP, my power meter, because that's where all test results are stored. And when you complete your configuration, it does send the test configuration to the source. It will also recognize if you have the wrong source connected. So if you have set up for a multi-mode test and you're connected to a single mode source, it will tell you that and let you know that the test is not going to work. Once I'm in the loss length, I do have an application which is called, or a utility that is called polarity check. And when I go into the polarity check, it just checks the polarity of the system that I'm connected to. And this is really helpful, especially in existing installations where you may not know what kind of polarity it is, and because we do pass-fail on polarity, you need to know what it is. So again, polarity check, very simple, straightforward way to find out the polarity of a system. The More button gives you some additional options, and starting at the top, you can look at your test results stored for that project. You can change whether this particular configuration is feet or whether all your tests are going to be measuring in feet or meters. You can turn your sound on or off. You may be able to hear the clicking, and when they connect together it makes a noise. You can also have a negative loss warning on or off. By default it's on, and we recommend you leave it that way. And you have an unsaved result warning. And this is, if you're needing to save results, you want to leave this on, and it prevents you from exiting the results screen without having saved results. If you're just testing and you don't care about saving, you're going to want to turn that off so you're not being annoyed by prompts to save results. The meat of setting up for a loss length test is under your test configuration. So once you go into your test configuration, you'll notice this looks pretty much identical to what the project setting looked like. And you have the ability through your menu to remove test configurations, add them, copy them, or set them active. And again, like the project, there is a on-screen shortcut to set something to be active. So I select it, and that's the warning that I mentioned earlier that you would see. I've set it to do a single mode fiber link test. I'm connected to a multi-mode source. It's going to give me a warning. But when I set this one active, I won't see such a warning. I then can enter into that test configuration. So I'm editing the test configuration, which is called MMF link, and it tells me when it was created. I get to choose my source type, whether I'm connected to a multi-mode or a single mode source. I get to set my test limit. And in this case, I'm using a link validation test limit, which means that I have to enter in dB values for the two wavelengths that I tested. For multimode, it will be 1300 and 850. I have to tell it what polarity, that's why the polarity check is useful, and I have to tell it the maximum length before it will cause a fail. Then I have my wavelength, my 1300 wavelength, what is considered a pass for it or a fail for it, and the same with the 850 nanometer. I then return back to my test configuration, and I'm able to set up my cable and connectors. So I just chose a generic MPO fiber. I've said that it's OM4, refractive index, which will have an impact on your length measurement, and what your connector type is. The reference method, one chord reference method is really the standard one. In some cases you may need to do a 3-chord, but with MPO, because of the pin-to-unpin, doing a 2-chord is really not possible. You are also able to select what fibers are used for pass-fail analysis. All fibers are always measured. It's just whether or not, if they had excessive loss, that would cause a fail or not. In this case, I've turned off 5, 6, 7, and 8 because SR4 technology does not use those, and although I want to see the loss of them, I don't want to have it impact my pass-fail. And with that, you are now set up to start testing, and the first step to that will be to set a reference. In this video, we're going to show how you perform a loss length test, and the first step in any loss length test is to do a set reference. In this case, I did set up to do a 1-chord reference, so between my source and my power meter, I have a single chord, and I know that I'm connected together because I can see on the screen it's showing me that they're connected together, and I also heard a beep because I had turned on the option to set beeps. So what I do then is I go under my menu, and I choose my set reference. It shows that the two are connected together, and it says referencing, and it takes a few seconds to set all the levels, and then it tells you that the reference has been successfully completed, and it tells you what to do next. You notice that it's telling you to connect the test cord to the MPOLP, which means that I disconnect my fiber from my power meter, never from my source. If I disconnect from my source, I need to re-reference. I'm able to take that cord and plug it into my patch cord microscope, and then I need to connect my other cord, which I had sitting in my patch cord microscope on my power meter. I need to take it and connect it to my port because I've already inspected it, made sure that it's clean. Now that I've got those things connected together, I can go with my patch cord microscope. I can inspect the fiber for this cord, this launch cord, and I connect up to the system that I'm going to be testing. Once I connect up, you'll hear the units will beep at each other and tell you that they're connected, and I simply press the auto test button. It tells me that it's testing. It takes somewhere around 6-7 seconds to test all 12 fibers. Remember that it's doing loss, length, and polarity here in this test. And it gives you a fail, and you're able to see the polarity passed, what the length is of the fiber, what your margins are, and you're then able to go into details to see the details as to what failed. And in this case, I had one fiber, fiber number 9, that had way too much loss and caused it to fail. I still may want that as a valid result, so I pressed my save button, and remember I had it set to fiber ID and it's set to auto increment, and then I just tap save again, and it has now saved that test result so that I can generate a report with this using FiberCheck Pro at a later date. All right, so we're trying to get a pass here. So we've done our set reference, and now all that you need to do when you've added in everything and connected up to what you're testing is press the auto test button. It takes somewhere around 6-8 seconds to test all 12 fibers, loss, length, and polarity, and then gives you a test result. And in this case, we've got a pass, and we can see that number 1 that we passed, it's not saved. We can see that our limit was the link validation. Our polarity was set to A. We expected A, and because it's green, we know that that passes. The length is showing 13.8 feet, and it passed. And that's my margin because I had set for a very long length for pass-fail. I see my 2 wavelengths, and I see the loss of them, and I see the margin of them. And if I wanted to go into detail, I can go into detail and I can go between my different wavelengths and my polarity. When I'm looking at my detail, I now see all my fibers. You notice that the 4 in the middle are grayed out, and that's because I set it to ignore those for pass-fail analysis. I see what my loss is of each of the fibers, I see what my margin is, and at the top right, I see what my limit setting was. At that point, when I've reviewed things, and I may just want to review things right from the summary screen, I hit the Save button. It tells me the fiber ID. In this case, I'm saving it to fiber ID number 2, and I press the Save button. Now that result is saved on the instrument for reporting later with FiberCheck Pro. So I'm just going to do the last little bit. Actually, I can't. Okay, so I'm going to hit auto test again just so we get to a point. We're just trying to do the last little bit of the video where we do a save because we had something went weird with the saving. So now I've performed a test. I can see that it passed, that I haven't saved it. I can see that my limit was link validation. I can see that polarity was set to A, and because A is green, it means that that was the polarity detected. The length passed, it was 13 feet, very short run here. And the margin, because I had such a long a long length set for the pass-fail analysis. I can see my 2 wavelengths, I can see the loss, and I can see the margin, and then I can choose to go into a detailed view. And when I go into a detailed view, I can choose to look at different elements. So if I start at the top, I see polarity, and I see that it's polarity A, it was expected A, the length, and the length limit. I can look at my 2 different wavelengths. I'll look at 850 here. I see each individual fiber, what its loss was and what its margin was, and in the top right I've got what the max loss is. So now I press the Save button, and I'm going to be saving this to fiber ID number 3, and I press Save again. And then it tells me saved fiber ID 3 successfully, and it returns me back to the screen that I was at. I could choose to save directly from my summary screen and not bother looking at the details. If everything passes, I may not want to do that. That's it. Yeah. Okay, cool. So this video we're going to cover using the patch cord microscope. And one of the features of the Smart Class Fiber product is that it has a workflow button. So here I am in my loss length application, and I've got my test cord plugged into my patch cord microscope, and I want to inspect it. I just press the workflow button, and immediately I'm in that application. And so the workflow button will toggle next to my probe and then back to my loss length application that I was running. One thing that's really useful about this is that because your connector clips in, your focus is always, and your alignment of your y-axis is always the same. Is it the y-axis? Okay, your alignment of your y-axis is always the same. And then all that you need to do is use the knob at the back to scroll through your x-axis and look at all those fibers. One thing that is also useful is that if you go to a low magnification, you are able to see a couple fibers, so it becomes very quick to scroll through and to do a quick visual check to make sure that all your fibers are clean. So I just scroll all the way through and say that everything looks good, and then I disconnect. I connect up to my system that's under test, and then when I plug in again, I'm right there, I'm focused, and I'm ready to scroll through. And in this case, we actually do see one of the fibers has some dirt on it. Something was on one of the fibers. Somewhere. There we go. So then you can disconnect. You can take your cleaner, give it a clean, plug it back in, and it's going to be looking right at that fiber that you're already at, and you can see that it's now clean. Scroll then through the rest of them. So the patch cord microscope adds a lot of value. It gives a place for you to keep your test cords and makes the inspecting of them very, very quick and easy. And because these are consumable items, you want to keep them in pristine condition. Then you can just use your button to go back to your loss length and connect up to your system under test and perform your next test. Video for the patch cord microscope. Smart Class Fiber products have patch cord microscope available to them, and we also have a workflow button here. So that when I'm in my loss length application and I've got my test cord here, and I've plugged that into my patch cord microscope, I'm able to just use my workflow button, and that takes me immediately to my patch cord microscope. The patch cord microscope, because it clicks in, is already lined up on my y-axis, so I don't have to be trying to find my fibers, and it's already lined up as far as focus is concerned, so I don't have to fiddle with my focus either. In this case, I'm in low magnification, which lets me see multiple fibers at once, and I can just then very quickly scroll across through the fibers, and you'll notice that some are dirty. I'll come back to that in a second, and look at all my fibers. Do a really quick visual inspection. Obviously, I don't want to plug this into anything, so I see that there's something that's really dirty. I unplug. I use my cleaner, give that a clean, plug it back in. Don't need to worry about focusing or y-axis again. That fiber looks better. I'm then able to scroll through the entire set of fibers, all 12 fibers, and notice how quick it is. Do a quick visual inspection. In this case, I'm not doing pass-fail. I'm doing a quick visual inspection and making sure that my test cord is in good shape. It is. I then disconnect, plug into the system that I'm going to test, and return back to my loss length application, test that. Unplug, plug back in, inspect, and just keep moving my way through the system that I'm testing. Are we allowed to use the phrase that remember your P's? Proper preparation prevents piss poor performance? Probably not. I think that will get cut. So this is the MPOLx demo guide available on the Velocity portal. You're going to need that in order to follow along with this demo guide. And I'm going to talk about preparation to start with. So you should make sure that you review the user manual for the MPOLx and be very familiar with how to use it. One of the first things you have to do is make sure that these things have the proper firmware installed, the most current firmware. So you go to scf.updatemyunit.net and download the latest firmware. If you want to see what firmware is on the unit, you go under your settings and you press the help button, and it tells you your power meter and your source must have the exact same configuration or exact same software level, and in this case you can see that they do. You do also need to make sure that both of these are charged. In this particular example, you'll see that my power meter's battery is getting almost dead. I don't want to go into a demo and have to be fiddling around trying to find power outlets and charging things. So both of your units should be fully charged up before a demo. You also want to make sure that your project is clean, and this is done on the MPOLP, but because the MPOLP pushes projects to the source, you do need to look in both of them and clean off any projects that you don't want there, and you do that just by using the menu, and you do remove. In this case, I've already done that, so I've got it nice and clean. I don't have a whole bunch of projects. You particularly don't want to have a project name of some competitor of who you're going to go in and see. What I recommend that you do, in this case I've created a project called Viavi Rocks, but you should create a project with the customer's name on it. You will then need to go in and configure that and set up how you want it to be. So with Fiber ID, I just keep things simple typically, and I have auto increment turned on. You need to also make sure that that project is active, and you do that by using the little A button to change which project is active. So you want to keep it as clean as possible. You don't want a whole bunch of clutter in there. And the same goes for your test configuration. So now if I go to my loss length application and I look at my test configurations, I can see that I just want to keep it nice and clean. So I've got a MMF link and an SMF link. Again, you may want to make these so that they're specific to the customer, maybe even put their name into the test configuration if you want. Keep your test configurations simple, and you want to show the customer the test configuration. We'll talk about that when we talk about performing the perfect demo. So set up your source the way that you want, your link validation, and your test limit, your cable and connector settings, your test reference method, and your pass-fail fiber selection. So it's pretty straightforward in what your setup is, and the demo guide, again, includes instructions as to what each of those should be. You are going to be demonstrating the patch cord microscope. So the other application that you want to go into is your patch cord microscope application, and you want to make sure that your profile is set up appropriately. In this case, I am doing multi-mode ribbon, and I've got the edition 2 of the 61300-3-35 standard set. That should by default set your adapter to the correct adapter. But the other thing that is really important is under the More button in your PCM settings to turn off Auto Center, because with MPO, because you're scrolling across, it's going to keep trying to zap a fiber to the middle. So turn off that Auto Center. And lastly, you want to make sure that you've got your focus adjusted, because once you adjust your focus once, as well as your y-axis, it's always going to line up. So you don't want to be in the demo fiddling around with focus and trying to find fibers. You want to be able to plug in and just scroll right through those fibers and make it really, really simple to do. The other thing that you should be doing before your demo is powering the units off by a single button push, because now it's in sleep mode, and when you're in front of the customer, you hit that power button and you've got instant on for the instrument. And that's it for your preparation. Yep. In order to perform a demo of the MPOLx, you need to have a certain amount of things with you. So you have to have an MPOLx kit, which consists of a power meter and a source. In this case, I'm using a multi-mode source, but it could be single mode. You need to have the correct FMAE adapters, and make sure that you've got the angled ones. I'm not sure if that will show up on the video. The angled ones for single mode and the flat ones for multi-mode. And the kits ship with this, so you should be fine. You also need to have all the right test cords. So you're going to have one cord that is pinned to pinned and another 2 cords that are unpinned to unpinned. Remember that the instrument is a pinned connection and you need to plug unpinned into it, otherwise you can cause damage. You should also have a P5000i, again with the appropriate tip on it, and it's good to have 2 P5000i's. You can also be using the Sidewinder if you're also trying to position that product. You need to have an MPO cleaning tool. Again, the kits come with this. They should be in there. If you don't, you need to get one of your own. Also recommend that you have something like this, which is a length of MPO fiber, which you may be able to get from one of your distribution partners or one of your reps, so that you have something to actually test. From a software perspective, you need to have the latest revision of FiberCheck Pro, which is available on updatemyunit.net, and you should have some collateral on your PC or tablet. Really, you should have the Better with Viavi video. If you can have that downloaded, play it off your iPad, whatever is great, or at least point the customer to it. And there are also several things that you could have printed off. So the Viavi Enterprise Test and Certification Brochure, the line card, the product brief for this product, and we also have the white paper on testing parallel optics that you could have printed off to provide to your customer. This is going to be a little bit of a walkthrough of doing a demo, and I'm going to verbalize what other videos that we've recorded need to be pulled from. One of the first things to do when you're doing a demo is to review the physical features of the product, and there is an overview video that is customer facing that you can watch that will help you with that. A couple things that I'll point out is you should talk about the test ports and how the source is PC or flat for the MPOLs 84, and you'll have a green cap on for the single mode source. Talk about this flap and how it this cover, how it protects the fiber port, this flap, how it protects the port even more. Talk about the battery. I'm not going to pick these up and turn them around, but talk about the lithium-ion battery. Show them the ports on the side, the USB ports that can be used for connect the P5000i or a Wi-Fi and Bluetooth dongle for cloud workflow. Talk about the patch cord microscope and how it's optional but provides a significant amount of value in terms of inspection and the XY axis. Again, there's a video on demonstrating that we'll get to. But in this phase of the demo, you're just going physically through the instrument itself. It's nice to have one of the units in the hands-free carrier. It's nice to have one of the units in the hands-free carrier so that you can show how easy it is to use a hands-free carrier. The kickstand is another thing. I'm going to maybe move one of these, point out the kickstand, and that you can fold that in, and that there's a stylus on the back there as well. 1/4-inch VGA screen. indicate that it is meant that you can navigate through the screen, through the keypad, or through a combination of both, and that it's a rugged screen, a rugged keypad. This is used in some outside plant environments, so it's quite tough. So then, when I should have actually said this, when you're showing them the physical features of the unit, leave the unit turned off, and then press the power button, turn it on. Remember that it was in sleep mode, so it turns on instantly and gives that kind of instant on appeal. And tell them that it is a sleep mode that it's a waking up from. You should be starting at the home screen and pointing out the different applications that are there: the patch cord microscope, the probe, the power meter, the loss length for the MPOLP, and the difference is that there's a source on the MPOLs. You can, if they're interested in, go into the power meter, go into the source, and look at those applications more, but really the value of this product is in the loss length application, and that's the one that we're going to be focusing on. So one of the first places to start in the demo is showing them how you set up a project. You don't need to go through every single menu because it just gets too involved. And you've already set up a project, so you'd come here, you'd see projects, you'd tap on the project, you'd show the project that's got their name on it, you go into it and you look at the settings of it, and again, some of the customer-facing videos can be used to get you familiar with this. Show them how you can have multiple projects and change which one is active in a very quick and easy way, and how you can organize your projects by removing, adding, copying, and setting active from the menu button. You really want to quickly get to your loss length application, and in here you're going to show them your test configuration. You really should point out first of all the polarity check, which is a nice, quick and simple, easy thing to do, and has a lot of value to it, and point out the value of that you can discover the polarity of a system that you're going to be testing. Then you need to get into your test configuration. Same thing as the projects, and the same look and feel as the projects, where you're showing that you can save specific test configurations and set them active, and by tapping, change which one's active, and that you can then go in and look at the details of them as well. The other thing, and again in one of our customer-facing videos, you'll get more information on that, and the demo guide gives you step-by-step instructions on it. You can also show them under the More button that you've got the ability there to change feet to meters, and that you've got some different options that you can turn on and off, and that the unsaved result warning is a good thing to have turned on if you need to be saving all your test results. Really, at this stage, what you're going to do is you're going to perform a set reference, and you're going to perform a test, and you're going to save the results. And again, all that information is available in the customer-facing video. We do recommend that as you have your cleaning stick, make sure that you clean everything, because if you don't, you will get fails when you go and perform your test. So be very diligent about keeping things clean. Show the patch cord microscope and show the value of that. Do tend to quote initially without the patch cord microscope, so that you have an apples-to-apples price comparison to the competition. But if you've sold them on the value of that, they're going to be willing to pay the extra money for that patch cord microscope. Make sure, and I indicated this in the customer-facing video, that you show how the workflow button can be used to take you through the different inspections and then back to your loss length application. A couple things to really point out to them at the end of this is that this product has a 3-year calibration cycle and a 3-year warranty, so there's really no risk for 3 years to the customer, and that is 10 to 20% less than our main competitor, which is Fluke with the Multi-Fiber Pro. In addition, you really need to highlight the length measurement that this has that Fluke doesn't have, that we have 2 wavelengths. So the sources are 2 wavelengths. They don't need to go through test everything at 1 wavelength and go through and test everything at the second wavelength. The patch cord microscope, I've talked about that a fair bit. And then combining our leadership in MPO from the loss length tester, the MPOLx, with the Sidewinder and with the T-Bird or MTS 4000.